All right, guys. We spent the past week or so talking about how to work with exponential equations and how to graph these things using like a table, right? So now what we're going to do is we're going to take this equation and like, apply it to a real life scenario. That's why it's called exponential growth and decay. It's when something grows very, very fast or it decreases very, very fast. So growth versus decay. And all we're going to do is we're going to take our equation and we're going to slightly kind of change it to match these word problems that we're going to talk about. Okay, so when we're talking about growth, remember something's growing very fast, we're going to change our equation slightly to look like this. Y is equal to a times 1 plus r power of t. Now the only difference is we're really just changing the part that's inside the parentheses. Instead of the b, we're using 1 plus r. Now r is the rate. Okay, so r is going to be like, how fast is this thing actually growing? Is it doubling? Is it tripling? What is it doing? So that's r. Okay, and we'll get to some more details in a second. When we talk about decay, obviously that's the opposite of growth, right? Decay is going up, growth is going up, decay is going down. So the only thing changed over here is going to be y is equal to a times 1 minus r. Okay, so that's the only difference between exponential growth versus exponential decay in terms of the equation. Okay, now it's important to know what each piece of this equation represents, right? So let's go and make a list right here. So the y, that's going to represent the final amount. Okay, so something's either growing or decreasing. The y value is how much is there at the end. Okay, versus a is the initial amount. Okay, and the initial just means the at the beginning. So this would be what you start with. Okay, and then r is the rate. Okay, it means like how fast is it changing? Okay, so how it changes. There's a slight catch to this one too that always throws students off. A lot of times questions will give you like a percentage, like this thing is growing by 5%. Okay, if they give you a percentage, we need to change it to a decimal before we can do anything. So let's make a little note. When we're talking about r in this equation, it does need to be in the form of a decimal. Okay, so if they give you percentages, you have to change it. And the last thing, t, that just represents time. Okay, how long are we asking for? Like how much did it grow in like 2 years, 3 days, 4 minutes, whatever it is. T is time. Okay, so that's the four components for the equation. Now the idea is we're going to do some word problems. I know everybody loves word problems, but the word problems are situations that where something is either growing or decreasing very, very fast. Okay. Now what I'm going to do right now is I'm going to go ahead and pause this video. I'm going to write down the question ahead of time, and then you can go and do the same thing. All right. So here's the problem we're going to work with. Again, I would recommend doing the same thing I did. Go ahead and pause the video, write all of it down, and then come back and press play so we can go through it. It just saves time on having to write it down during the video. Okay, so here's the question. It says the attendance of a music festival hit 150,000 people in their first year. Okay, they expect it to grow by 8% per year. And the first thing they want you to do is write an exponential model, which is the same thing as an equation to represent this situation. Okay, so the first thing you should do is decide, well, is this going to be a growth question or a decay question? Now, it is a little bit obvious because in this question, it does actually use the word grow. So we do know this is going to be a growth question. All right, so the equation we're working with is y is equal to a times 1 plus r because it's growth, right? If it's decay, it'd be 1 minus r. Then all we have to do is we have to go and figure out, okay, what are the pieces they're giving us and what is it they're actually asking for? Now in this one, they haven't actually asked a question yet. They just want us to come up with the equation. So we kind of have to replace the values. Okay, so let's go through and kind of circle the important information here. So first sentence, The attendance of a music festival hit 150,000 people. Okay, so that's probably an important number. Okay. And then they expect to grow by 8% per year. So here's what I was talking about. Well, where they sometimes give you a percentage. Okay, so that's probably important. Okay. And then they want you to build a model. Okay, so we have to know where these two things are going. Okay. Well, the 150,000 is their first year, right? So that would be the initial amount. Okay, so that's going to be the A value. Okay, so we can kind of rewrite our equation. Y is equal to 150,000. Okay, and then times, it's always going to be 1 plus, or if it's decay, 1 minus. And then R is 8%. Now, quick review on percentages. Remember, when you go from a percent to a decimal, you have to you have to move the decimal place twice, right? So technically the decimal place would be here. So 8% as a decimal is actually 0.08. Okay, if you put 0.8, that's saying 80%. Very big difference there. Okay, so 8% is 0.08. It's like change, right? 8 cents versus 80 cents. Okay, so be very careful. 8% is 0.08. So we can put that in there. Now, so far in our question, they have not said anything about time. They just said write a model. So here's our model. Okay. So now once we have this model, they can literally ask us any kind of question in regards to time. They could say, how many people will they have in 5 years, 10 years, 20 years, whatever number we want to figure out. Okay. So let's go and add a question here. Let's say the question is, how many people will they have in 5 years? Okay, so that's a pretty basic question, right? The 5 year plan. How many people are you gonna have in 5 years if you expect this 8% of growth? Okay, so now that we have an actual time, now we can actually go and replace t, right? T is in time, which is in this case is 5 years. Okay, so let's write it out. Y is equal to 150,000 times, we can go ahead and add these together. 1 plus 0.08 is just 1.08. And now we know time, they're asking about 5 years, so power of 5. Okay. Okay, and then now we have to figure out what this is. All right, so um, probably definitely want to use a calculator. Okay, and order of operations says you have to do the exponent first, right? Well, parentheses and then exponent, but we already add those together, so now we can work on the exponent piece. So in a calculator, the way you would enter it in, right off to the side over here. We'll do this in class live as well, but for a calculator. Okay, the keys you would enter would be 1.08. Okay, and then find the key that looks like this, where it usually just says x power of y. Okay, that's basically saying the next number you enter in is the exponent we're trying to figure out. So 1.08, find that x power y key, and then press 5. Okay. On the iPhone, it's once you turn your phone sideways, it's like the second row of keys. It's probably similar on other phones as well, but I know for sure it's like that for iPhone. So if you enter that incorrectly, you should get uh, this. So y is equal to 150,000, and then 1.08 to the power of 5. If you do it correctly, you should get 1.469. Okay, you might get more than 3 decimal places, but I just rounded it off. And then we can multiply this in the calculator, 150,000 times 1.469. And if you do that correctly, you should get 220,399.212. Okay. So again, make sure you guys know how to do that. Know how to enter in a calculator. We'll work on it live as well, so make sure you know how to do that. But now we actually have to answer the question. Now, Whenever we're dealing with word problems, it always makes sense that you should be answering it with a sentence, right? If they ask you in words, you should answer in words. So this is our expected population. Now you have to kind of do some logical reasoning real quick. Um, can you have 0.212 of a person? No, that doesn't make any sense, right? So the population, we do have to kind of round it down because we can't round up, right? You can't have um, zero point 0.2 of a person. Okay, so when you answer the question, it'd be something like write a sentence, a complete sentence. It says they are expected to have 220,399 people in 5 years. Okay, and notice I did not include the decimals because again, you can't have zero point 0.2 of a person. Okay, so it's rounded down. Okay, and that's how you approach these questions. So it's all about making sure you know what the equation is looking like, right? Y is equal to A times 1 plus R or minus R, depending on the question, to the power of T. Okay. Now we'll be working on these throughout the week. This is just the first one. And then there'll also be like assignments based off this throughout the week.